Good afternoon, guys. We are pushing along. This is our last set of notes for this week. This is only the second set of notes this week. Next week, we're going to plan on Monday, Wednesday, and Friday. And I'm going to shorten the homework assignments beginning with today's assignment. So I do really want you all to start getting these submitted to me. I know some of you are banking on the simple fact that you're under the impression that the school districts are just going to pass everybody, and that has never one time been discussed anywhere across the state. So it's important that you are trying to keep up with this work, and I'm trying to make it as easy as possible for you. What we're looking at today are absolute value equations. Remember, with absolute values, it measures a number's distance from zero. So there's symmetry to this. If we're looking at 5 is 5 units from 0. Similarly, -5 is also 5 units from 0. So both of those values could be a solution to an absolute value equation. And we're going to see that here with warm-up number 1. If the absolute value of x is 7, what are the possible values of x? Well, we know that it has to be x is either -7 or +7 because the absolute value of both of those numbers is 7. With number 2, however, it says if the absolute value of x equals -4, what possible values of x exist? We cannot take the absolute value of a number and generate a negative solution. And that will always be the case with absolute value equations. So whenever you have an absolute value equal to a negative number, it is going to be no solution. It can't be done. And that's going to lead us into our discussion here on absolute value equations. I'm not going to go through every one of these. I'm trying to keep the video short. You don't need this much repetition to understand how to do it, so I'm going to kind of pick a few and go on. With number 3, that's the first one we'll look at. When you're doing absolute value equations, the first thing you want to do is make sure you get the absolute value by itself. As long as the absolute value is the only thing that exists on one side of the equation, you're good to go with the next step in the process. We see that in number 3, absolute value is the only thing on the left side of the equation. So what that means is we can continue with the next step in the process. And that next step is to simply create 2 cases. The first one is x minus 9 equals 5. Same original problem, we just don't have the absolute values in it. The second case is x minus 9. We don't change what's inside the absolute value. Equals -5. We just take the opposite of what's on the right-hand side. So to solve these, I would add 9 in both cases. On the left, I get x equals 14. On the right, I get x equals 4. And there's my 2 solutions. Number 6 is an example where the absolute value is not by itself yet, but we can manipulate the equation to get it to that point. So I have this 3 in front of the absolute value. So I'm going to divide everything by 3. And what that gives me is the absolute value of m plus 8 equals 13. These 3's cancel. 39 over 3 is 13. And now I do have the absolute value by itself, and I can generate my 2 cases. The first one is m plus 8 equals 13. The second one is m plus 8 equals -13. And I'm going to subtract 8 in both cases. And that will give me m equals 5 on the left and m equals -21 on the right. And those are my 2 solutions. Number 8 is similar in the fact that the absolute value is not by itself. We need to get rid of that -2 in the denominator. The way we do that is multiply everything by -2. And so that's going to give me y minus 10 equals +12. Now that I've gone from a -6 to a +12, I can solve this. So I have y minus 10 equals 12. Y minus 10 equals -12. And I'm going to add 10 on both sides. And that gives me y equals 22 and y equals -2. The last 2 examples that I want to look at are numbers 12 and 14. Number 12, there's nothing special about it that I want to look at. It's just that you have a couple more operations that we have to address before the absolute value is by itself. The first thing is to subtract the 8 from both sides. And that gives me negative 24 is equal to negative 12. And then the final step is to divide everything by negative 12. Well, when I divide everything by the negative 12, I do end up with a positive 2 on the left. And so this does give me absolute value equation that is that will contain solutions. So I write k over 5 equals 2, k over 5 equals negative 2, and then I multiply both sides by 5. And I get k is equal to 10, k is equal to negative 10. 14 is the interesting case because we do have an extra step at the end of number 14 before we can say that we're finished. First, we divide everything by 2. And that's going to give me the absolute value of h plus 8 equals 7h. And now I can do my two cases. Here I want to subtract h on both cases. I'm going to get all my h's together. And on the left, I'll divide by 6, so that gives me h is equal to 4 over 3. And on the right, I want to divide by negative 8. That gives me h is equal to negative 1. Now, normally this would be the point where we stop. However, because this problem has variables on both sides of the original equation, we need to check to make sure that both solutions work. Because we could end up having what's known as an extraneous solution, which means one of the solutions we found solves the individual component that we solved for, but it doesn't solve the actual equation that we began with. So we do that by just simply substituting our solutions into the original problem and see what we come up with. So the first one I'm going to do is I'm going to substitute in 4/3 into the original problem, and that's going to give me 2 times 28 over 3 equals, that's 56 over 3. 2 times 28 over 3 is 56 over 3. So we have 56 over 3 equals 56 over 3. That is a true statement, so that means that 4/3 is a valid solution to our original problem. Then we want to test negative 1 and see if that works. So we have 2 absolute value of negative 1 plus 8 equals 14 times negative 1. 2 times 7. 2 times 7 is 14. 14 does not equal negative 14. So what that means is that h equals negative 1 is not a solution, and h equals 4/3 is the only valid solution to this problem. So only do the odd problems on the assignment. Remember to try to start getting this stuff turned in as quickly as you can. I'm leaving as much of it up on the website, even the stuff from before we went on NTI. So if you have zeros for anything in the grade book and it's prior to NTI, go back and look for it and do it and submit it to me, please. I want to see you guys pass. So I hope everybody's doing well, and I'll be talking to you next week.